students, the Apollonius Theorem in triangle ABC. See here, in triangle ABC. Okay, here in triangle ABC, M is the midpoint of side BC. M is the midpoint of the side BC. Okay, and then AB square plus AC square is equal to 2AN square plus 2BM square. That we have to prove out. That is AB square plus AC square is equal to 2AN square plus 2BM square. So how can we prove out this theorem, students? So first we have to draw the figure. So here we draw the figure triangle ABC, AD perpendicular to BC, and M is the midpoint of the triangle. M is the midpoint of the side BC, students. Okay, so given in triangle ABC, M is the midpoint of side BC, and we have to prove that AB square plus AC square is equal to 2AM square plus 2BM square. So now here this figure is insufficient to prove this one. So here we consider that we draw segment AD perpendicular segment BC. Here we draw the segment AD perpendicular to BC. Now here we can see how can we prove this theorem, which is known as the Apollonius Theorem, students. Which is known as the Apollonius Theorem. Okay, see, that is here proof if segment BC, that is segment AM, is not perpendicular to segment BC. Okay, segment here, see, the segment AM is not perpendicular to the segment BC. Okay, and here we have then out of angle A and B, and angle ANC. See here in the figure, angle A and B. So this one, students, okay, that this one A and B, and the ANC, this one, that is this angle ANC. That one is obtuse angle and the other is the acute angle. Okay, here see, students, that is what is the concept, that is M is the midpoint of segment BC. Okay, there is M, and due to the M there are the two types of the angles made. Okay, and the first angle, that is the AMB, which is the obtuse angle, and the second angle made, that is the AMC, which is the acute angle. Okay, so in the figure that angle AMB is obtuse angle and angle AMC is an acute angle. Okay, so now from the first and second equation, that is we have, if it is obtuse angle, then we can get that AB square is equal to AM square plus MB square plus 2BM multiplied by MD. Okay, and if it is acute angle, then we have AC square is equal to AM square plus MC square minus 2MC multiplied MD. Okay, so now here AC square is equal to AM square plus MB square. MC, that is MC is equal to BM. So here we can replace this MC square as MB square. Here also minus 2MC, that means minus 2BM, and multiplied by MD. So this way we can prove this Apollonius Theorem. And here, now, here see the next part is that adding 1 and 2, AB square plus AC square is equal to 2AM square plus 2BM square, and this is known as Apollonius Theorem. So students, this is the Apollonius Theorem. AB square plus AC square is equal to 2AM square plus 2BM square. Okay, let's see the example, students, on the base of the Apollonius Theorem. So example 1, in this figure, segment PM is a median of triangle PQR. Okay, segment PM, see, segment PM is the median of the triangle PQR. That means we can say N is the midpoint of QR. Okay, and PM is equal to 9, PQ square plus PR square. PQ square plus PR square is equal to 290. Then find QR. We have to find out this QR. Okay. So here solution, that in triangle PQR, segment PM is a median. Okay. So M is the midpoint of segment QR. Okay. So now here M is the midpoint of the segment QR, and then we here say that as per the given figure, we can say that here that QM is equal to MR. This QM is equal to MR because M is the midpoint of the segment QR. Okay, student, this way. So half of QR. Now here PQ square plus PR square. Now as per the Apollonius Theorem says that the PQ square, this segment, that is the PQ square plus this segment, that is PR square plus PR square. PQ square plus PR square, students, is equal to 2PM square, this median, that is a 2PM square, and this half part, that is a 2QM square, student. So now here PQ square plus PR square is given, and that is the 290, student. So here we substitute 290 directly, and then 2 multiplied by 92. Sorry, square of 9, student, because the PM is 9, so square of 9, and here plus 2QM square. So here 290 is equal to 2 multiply 81 plus 2QM square. That means 290 is equal to 162 plus 2QM square. So 2QM square is equal to 290 minus 162. 2QM square is equal to 128. So QM square is equal to 64. So QM is equal to 8. So QR is equal to, now QM is equal to 8. So that's why QR is equal to 2 multiplied QM. So 2 multiplied 8. That means QR is equal to 16, students. Okay. So this way we can find out the line segment from the Apollonius Theorem, students. Okay. Now see the next one example, students. Prove that the sum of square of the diagonals of a rhombus is equal to the sum of the square of the sides. Okay. So now here the given information is the sum of the square of the diagonals of a rhombus. So we here draw the figure of rhombus. Okay. We draw the figure of the rhombus and name it as the PQRS. Okay. Name it as the PQRS. Okay. PQRS. See here. PQRS. Okay. And here also the diagonals. We draw the diagonal, that is the QS and the PR, and they intersect at the point T. And in the rhombus, that all the sides are congruent. So here mark of the sides. Okay. So now here given, we write the given quadrilateral PQRS is a rhombus. Diagonals PR and SQ intersect each other at point T, and we have to prove that the sum of the squares of the diagonal, sum of the squares of the diagonals are PR and SQ. So square of diagonals, that is PR square and the QS square, and the sum means addition. So PR square plus QS square, and that is equal to the sum of the square of the sides. There are the four sides. So here square of the side, that means PS square, SR square, QR square and PQ square. Okay, so make them square and add them. Okay, so here we have to prove that PS square plus SR square plus QR square plus PQ square is equal to PR square plus QS square, students. Okay, now we have to prove it. How can we prove it? That is, diagonals of a rhombus bisect each other, and so by Apollonius Theorem. Here we apply the Apollonius Theorem, students. See in the figure, that is, if you see the figure of the quadrilateral PQRS, and that quadrilateral is nothing but the rhombus. Okay, so here in this PQRS we apply the Apollonius Theorem. So let us see how can we apply the Apollonius Theorem. Okay, students, here. Okay, so now here we take the triangle as the PQS. Okay, first we take the triangle PQS. So here in this triangle PQS, that PT is the median of this triangle. That means the T is the midpoint of QT and the TS. Okay, students, and so here we say that the PQ square plus PS square, okay, as per the Apollonius Theorem, PQ square plus PS square is equal to 2PT plus 2QT square. 2PT square plus 2QT square. Okay, this way, students, we only take this triangle. In this triangle we apply the Pythagoras theorem, and the triangle name is PQS. In triangle PQS. Okay, so call it as the first equation, which is get by the Apollonius theorem. Now the second part is that we choose this triangle, student, that is QRS. Okay, we choose the QRS, students, that is triangle QRS. So by applying the Pythagoras theorem in this triangle, so we have, that is, QR square plus RS square is equal to 2RT square. Here say QR square plus RS square plus 2RT square plus 2QT square plus 2QT square, and call it as the second one equation, students. Now here these two equations, added these two equations, we have PQ square plus PS square plus QR square plus SR square, which is equal to 2PT square plus in the bracket PT square plus RT square plus 4QT square. Okay, so now here 2 PT square. Now RT square is nothing but the PT square. Both the segments are equal, so we write it here as the PT square. So now plus 4QT square. Now 2 here 2 multiply 2 PT square. So that means 4 PT square, and here 4 QT square. So 2pt whole bracket square plus 2qt whole bracket square, and that means 2pt means pr, that is a pr square, and 2qt means a qs, that means qs square. So here we can say that pq square plus ps square plus qr square plus sr square is equal to pr square plus qs square. That means the sum of the square of the sides, the sum of the square of the sides is equal to the sum of the square of their diagonal, and this can be proved with the help of Apollonius Theorem, students. Students, thank you for watching our videos. Achieve your success with us. I sure that you will get 100% success in maths. So watch our videos continuously, regularly. Like our videos, share our videos to your friends.